Astronomers have discovered remnants of planets with Earth-like crusts in the atmospheres of 4 nearby white dwarf stars. This offers a glimpse of the planets that may have once orbited them up to billions of years ago. These crusts are from the outer layers of rocky planets similar to our Earth and Mars, and could give astronomers greater insights into the chemistry of the planets that these dying stars once hosted. This discovery was reported on the 11th of February 2021 and includes one of the oldest planetary systems ever observed by astronomers over the years. The research team was working to analyze data from the European Space Agency's Gaia telescope of over 1,000 nearby white dwarf stars when they came across an unusual signal from one particular white dwarf. The research team utilized spectroscopy to analyze the light from the star at different wavelengths, which allows them to detect when elements in the star's atmosphere are absorbing light at different colors and determine what elements those are and how much of it is present. They also inspected the 30,000 white dwarf spectra from the Sloan Digital Sky Survey published over the last 20 years. The signal matched the wavelength of lithium, and astronomers soon discovered 3 more white dwarfs with the same signal, one of which was also observed with potassium in its atmosphere. By comparing the amount of lithium and potassium with the other elements that were detected, sodium and calcium, they discovered that the ratio of elements matched the chemical composition of the crust of rocky planets like Earth and Mars. If those crusts had been vaporized and mixed within the gaseous outer layers of the star for 2 million years. A member of the research team has mentioned that in the past, they've seen all sorts of things like mantle and core material, but they've not had a scenario with a definitive detection of planetary crust. Lithium and potassium are good indicators of crust material. They are not present in high concentrations in the mantle or core. Now we know what chemical signature to look for to detect these elements. We now have the opportunity to look at a huge number of white dwarfs and find more of these elements. Then we can look at the distribution of that signature and see how often we detect these planetary crusts and how that compares to our predictions. The outer layers of the white dwarfs contain up to 300,000 gigatons of rocky debris, which includes up to 60 gigatons of lithium and 3,000 gigatons of potassium, which is equivalent to 60 kilometer sphere of similar density to Earth's crust. The amount of crust material detected is similar in mass to that of the asteroids that we have observed in our own solar system. The astronomers believe that what they are observing around all 4 stars is material broken off from a planet rather than an entire planet itself. Previous observations of white dwarfs have discovered evidence of material from the inner core and mantle of planets, but no definitive evidence of crust material. Crust is a small fraction of a planet's mass, and the elements detected in this study are only detectable when the star is very cool. It should be noted that white dwarfs are in the dying phase of their life cycle, as they have burnt out their fuel and have gotten cold over billions of years. These 4 white dwarfs are thought to have burnt out their fuel up to 10 billion years ago and could be among the oldest white dwarfs formed in our galaxy. It should be noted that in one case, they were looking at planet formation around a star that was formed in the galactic halo 11 to 12.5 billion years ago. Hence, it must be one of the oldest planetary systems known so far. Another of these systems formed around a short-lived star that was initially more than 4 times the mass of the Sun, a record-breaking discovery delivering important constraints on how fast planets can form around their host stars. Among the oldest of these white dwarfs, one is 70% more massive than average, and so its large mass could normally cause any material in its atmosphere to disappear relatively quickly, leading the astronomers to the conclusion that it must be replenishing the crust material from a surrounding debris disk. Furthermore, the astronomers detected more infrared light than expected from the white dwarf alone, which indicates a disk being heated by its star and then re-radiated at longer wavelengths. As they understand it, however, rocky planet formation happens in a similar way. In a different planetary system, initially they are formed from similar material composition to the star, but over time these materials separate, and of course you end up seeing different chemical compositions in different parts of the planets. We can see that at some point that these objects have undergone differentiation, where the composition is different to the starting composition of the star. It is now well understood that most normal stars, like the Sun, harbors planets, but now there's the opportunity to look at the frequency of different types of materials as well.